All right, continuing on with lesson 14, what we're going to do, problem 14.3, is we're going to look at an alternate approach for the Pythagorean theorem. This one is a little bit more hands-on. It should help you see this relationship moving forward. So, number one here says to drag the points into place in the applet below. So we see the applet here. And what I'd like you to do is just play around with it and drag the points into place. For example, I'm going to take this yellow one and I'm just going to drag it down here into its place. Then I'm going to take the green one, I'll put it into its place, the red, this purple color, and finally this blue color. Okay? So there we go. We just drag them directly into place, and we can certainly look at this now and see the relationship between these two squares. We have a small square that has an area. If this side length is a, it has an area of a times a, or a squared. And then let's suppose this longer is b, so we have b times b. The area there is b squared, so I drag all those out for b squared. And notice they equal to the square of that has this side length, or c. So remember, I told you that Pythagorean theorem really, instead of thinking a squared plus b squared is c squared, it's the sum of the squares of the legs is equal to the square of the hypotenuse. Okay, so we can come down here, and what do we notice? Well, we notice that the sum of the areas with side lengths that are equal to the legs okay, so those areas are equal to the square of the hypotenuse. Okay, so that's what we should recognize. The sum of the squares of the legs is equal to the square of the hypotenuse. How does this prove the Pythagorean theorem? Well, it shows that the Pythagorean theorem is true for areas, not just algebraically. That's kind of what it shows us here. Okay. Perfect. So that's it for this problem, and that's it for lesson Unit 3, Lesson 14. That's all I got for you guys. Thanks a bunch.